Lesson 46, solving problems using scientific notation. Just to review with scientific notation, we use scientific notation to write really large numbers or very, very small numbers, especially numbers that have a lot of zeros in it. And how do we write them in scientific notation? You have a decimal between, it has to be between 1 and 9. That's multiplied by a power of 10. And so you can see right down here, this is scientific notation. So as long as you have one digit to the left of the decimal point, and it has to be a number between 1 and 9. And so today we're going to be looking at multiplying and dividing in scientific notation. And when we multiply in scientific notation, we multiply the coefficients or the two decimals. It's like here 3 times 5 to give you your 15. And then you multiply the powers of 10. 10 to the second times 10 to the fourth. And remember, when you multiply like bases, you add the exponents. And then when you divide in scientific notation, you do the same thing. You divide the coefficients, and then you divide the powers of 10. And remember, when you divide the powers of 10, you subtract the exponents. So let's take a look at an example. Here we have 1.2 times 10 to the 5th times 3 times 10 to the 5th. We want to find the products, so we're just going to multiply those. We have 1.2 times 3 gives us 3.6. Then we're going to multiply that by 10 to the 5th times 10 to the 5th. That is 10 to the 10th. And then the last thing we have to check for to make sure that our decimal is in scientific notation. It is, so we have our answer. Next one, we have 4.0 times 10 to the 5th, 10 to the 4th times 5.0 times 10 to the 5th. That's going to give us 20 times 10 to the 9th. But that's not in scientific notation. So in order to write that in scientific notation, I need to move the decimal point 1 to the left. So now I have 2 times 10. But since I gained a decimal place, I need to add 1 to my exponents. So now it would be 2 times 10 to the 10th. Next one, we got 2.4 times 2 gives us 4.8. This is all times 10. 6 plus 5 is 11. So we to 10 to the 11th power. The right hand side, we got 1.25 times 10 to the 4th times 2 times 10 to the 6th. So 1.25 times 2 gives us 2.5. Speed times 10. 4 plus 6 is 10, so to the 10th power. 4.0 times 4.0 is 16. This is times 10 to the 10th. And since I don't have that in scientific notation, I need to move it 1 to the left. So this is 1.6 times 10. Since I gained a decimal point, I add 1 to the exponent to be 10 to the 11th. And the last one on the slide, 2.5 times 5 gives us 12.5 times 10. 6 plus 7 is 13. Need to put that in scientific notation, so move it 1 to the left. So this would be 1.25 times 10. Since I gained a decimal point, I need to add 1 exponent, so that would be 10 to the 14th. Let's look at some with word problems. Light travels at a speed of about 300,000 kilometers per second. An hour is 3,600 seconds. Estimate or write both numbers in scientific notation. So let's do that. So 300,000 would be 3.0 times 10 So decimal points here, so 1, 2, 3, 4, 5, so 10 to the 5th. And the other one would be 3.6 times 10, so 1, 2, 3 to the 3rd power. Now we need to estimate the distance light travels in an hour using scientific notation. So let's estimate that. So we're going to just multiply our two numbers here. So it'd be 3 times 3.6, which gives us 10.8 times 10 to the 8th power. Put it in scientific notation. You need to move it 1 to the left. So this would be 1.08 times 10. Since I gained a decimal point, I need to add an exponent. So it would be 10 to the 9th kilometers. And the next one on the right-hand side, 1 day is 86,400 seconds. Express this number in scientific notation. So 8.64. You could add the zeros at the end, you don't need to. Times 10, I moved it 1, 2, 3, 4 places. So it'd be 8.64 times 10 to the 4th. How far does the sun's light travel in a day? So to solve this one, we're going to take our answer that we just have, so 8.64 times 10 to the 4th. We're going to multiply that by our answer, the speed that light travels, which is 3.0 times 10 to the 3rd, or 10 to the 5th. That's what we just got over here. So that gives us 25.92 times 10 to the 9th. But I need to have it in scientific notation, so I move it 1 to the left. Gained a decimal point, so the answer would be 2.592 times 10 to the 10th. Let's look at some division. So we divide our two decimals, so 1.44 divided by 1.2 gives us 1.2 times 10. This time we subtract the exponents, so 12 minus 8 is 4. Next one, we got 3 divided by 4 gives us 0.75 times 10. 8 minus 4 is 4. But it's not in scientific notation, so I need to move it 1 to the right. And since I lost a decimal point, I need to subtract 1 from the exponent. So this would be 7.5 times 10 to the 3rd power. And the last one here, on this side, we got 7.5 divided by 2.5 gives us 3 times 10. 6 minus 6 is 0. That's just going to give us 1. So you can either keep it as 3 times 10 to the 0, or it would just equal 3. And we got 3.6 divided by 3 gives us 1.2 times 10 to the 4th, just subtracting it. It's in scientific notation, so we're good. We got 6 divided by 4 gives us 1.5 times 10. 8 minus 8 is 0. So you can either keep it as 1.5 times 10 to the 0, or this would just equal 1.5. And the next one, we got 1.2 divided by 3 gives us 0.4. Times 10 to the 4th. It's not in scientific notation, so I need to move it 1 to the right. It means I lost a decimal place. So this would be 4 times 10 to the 3rd power. And the last one on this slide, we have 3 divided by 8 gives us 0.375. This is times 10. 9 minus 4 is 5. Not in scientific notation, move it 1 to the right. So our answer would be 3.75 times 10 to the 4th power. And let's take a look at some word problems. Earth's average distance from the sun is about 150 kilometers. Light travels about 300,000 kilometers per second. Express both numbers in scientific notation. So we got 150 kilometers. And I'm just going to write that up here. So that's 150. So if we write that in scientific notation, that would be 1.5. And moved it 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th. And light travels at 300,000 kilometers, so 300,000. This would be 3 times 10 to the 1, 2, 3, 4, 5 to the 5th power. Estimate how long it takes the sun's light to reach Earth. And remember, time equals distance divided by the rate. So the distance is 1.5, so it's 1.5 times 10 to the 3rd. We are dividing, or not the 3rd, it'd be the 8th, divided by 3 times 10 to the 5th. So 1.5 divided by 3 gives us 0.5 times 10 to the 3rd. We need to have it in scientific notation, so move it one place to the left, or one to the right, subtract a decimal place, so it'd be 5 times 10 to the 2nd power. And if Mars is 225 million kilometers from the sun, how long does it take light to travel from the sun to reach Mars? So if we write 225 million kilometers, like the Earth was 150 million kilometers, so Mars in scientific notation would be 2.25 times 10 to the 8th. We're going to divide that by 3 times 10 to the 5th. So 2.25 divided by 3 gives us 0.75 times 10 to the 3rd. Put in scientific notation. Move it 1 to the right, so we have 7.5 times 10 to the 2nd. So that is our lesson today on scientific notation using multiplication and division.